Hi, sixth graders. Your notes today are on Introduction to Energy, section 2.1. Please make sure to fill out the note sheet either electronically or if you want to print it out and write it on a sheet of paper, you can do that as well. But you will want to make sure you have notes because all you're doing this week is the notes and then your activity with it. Okay. Our objective is I can describe how energy is conserved as it transforms between different forms. And we talked already about the law of conservation of mass. And what that law tells us is that when something undergoes a chemical change or a physical change, or if it undergoes a change in state of matter, okay, the amount of matter, the amount of mass, the amount of stuff always stays the same. Well, the same law applies to energy, but we call that the law of conservation of energy. So energy also changes from one form to another, but the amount of energy always stays the same. So that's what we're going to be looking at, how it's conserved as it changes from one form to another. Okay, and then our essential question is, what is energy? So quick review, we have two main types of energy. We have kinetic energy and potential energy. And the definition of energy is the ability to do work. And kinetic energy is the energy that an object has due to its motion. So anytime something is moving or has motion, we would say it has kinetic energy. And this even applies to when we're talking about really small particles or small molecules. When those objects are moving, we would call that type of energy kinetic energy. We also have potential energy, and potential energy is the energy of an object due to position, condition, or composition. We also talk about potential energy as energy that something has that's stored, okay? It's waiting to be used. Objects usually have both potential and kinetic energy, and it just kind of transforms from one form to another. And we talked about the skateboarder or roller coaster example earlier. So as potential energy up at the top when he's not moving, once he starts moving down the ramp, it changes into kinetic energy. And then once he stops at the top, he only has potential energy. And so potential and kinetic energy is always kind of converting in between each other. But the total amount always stays the same. So kinetic energy is the energy of movement, and potential energy is stored energy. And these two types of energy can take many different forms. And that's what we're going to be talking about today, these main different forms of energy. So the 7 main forms of energy, we have mechanical energy, sound energy, electromagnetic, which includes solar and light. We have electrical, we have chemical, which is stored or potential energy. We have thermal energy, and we have nuclear energy. The first type of energy is mechanical energy, and we're going to call this the energy of movement. So the definition of mechanical energy is it's the sum of an object's potential and kinetic energy. Now we know that objects always have a little bit of potential, a little bit of kinetic energy, and it kind of transforms from one to the other and back again. So we're going to just call that mechanical energy. So anytime something is moving, even if it's not moving at the second, we would call that mechanical energy. So a moving car, a bike, a skateboarder, a skier, anytime they're moving, we call it mechanical energy. The second type of energy is called sound energy, and sound is something that you can hear, all right? Sound energy is a form of kinetic energy, and it's caused by the vibration of waves. So what happens when sound is passed through something is you have little particles that make up different objects, right? And we know in a solid, they're closer together. In a liquid, they're farther apart, and in a gas, they're even farther apart. But what happens is sound gets passed from one particle to another, and it kind of keeps getting passed down, much like you might if you were playing like telephone or something, right? And it keeps getting passed from one particle to another. Now, the thing about sound that's tricky is that there has to be particles in order for sound to travel through, and we call that a medium. So we say that a medium is a material that has molecules like air, water, metal, etc., where sound can be passed through. Okay. Now the place where there isn't a medium is in space, and that we would call that a vacuum. And so a vacuum is a place where there isn't a lot of particles, and so sound can't get passed from one object or one particle to the next. So you actually can't hear sound in space because there's not enough particles to pass it through. But since sound is heard as vibrations of the particles, we would call that a form of kinetic energy. The third type is electromagnetic energy, and electromagnetic energy is also passed in the form of waves. Electromagnetic energy comes in many different forms, and we can look at this. It's called the electromagnetic spectrum. The two main ones that we're going to look at are visible light, so light we can see, and also ultraviolet light from the sun. And so we would say that light and solar energy are both forms of electromagnetic energy. We also have X-rays, that's a type of electromagnetic energy. We have infrared radiation, which is if you put on night vision goggles, that would be infrared, microwaves, radio waves, and gamma rays. And electromagnetic energy is also a form of kinetic energy because the waves are moving. But the difference between this and sound waves is where sound waves need a medium in order to pass through, electromagnetic waves don't. They can travel through the vastness of space, which is good because we get all of our light and solar energy from the sun, and the sun is in space. So that's the main difference between sound energy and electromagnetic energy. The next type is electrical energy, and electrical energy, also known as electricity, is a form of kinetic energy. So anytime you plug something into an outlet in your wall, that's using electrical energy. Chemical energy is the main type of potential or stored energy. And what happens with chemical energy is stored in the bonds between molecules. So when molecules join together in a chemical reaction to form things, they're bonded together by chemical bonds. And energy is stored in those chemical bonds until those bonds are broken, that energy is released, okay? So an example of this, anytime we see batteries, food, matches, gasoline in your car, any of those things is stored energy. So if I were to eat a hamburger, let's say, when my body breaks down that hamburger in my digestive system and breaks it down into usable nutrients, what it does is it also releases some of those bonds and it releases the energy into my body. Now my body can use that energy to keep it at a good temperature, so as heat energy, can use it as mechanical energy to keep my heart beating, to let me move, okay? But the food itself is chemical energy, but my body converts it into usable kinetic energy. Thermal energy is the next one we're going to talk about, and thermal energy is the kinetic energy of how fast an object's particles are moving. So we talked about in solids, they're just kind of vibrating in place, in liquids, they're moving a little faster, and in gases, they're moving pretty fast, okay? But all of those particles are moving. And so all of those particles have thermal energy, and the faster they're moving, the more thermal energy they have. And the last one, nuclear energy. You're not going to be, when you're doing your energy transformations, you won't really have this as any of them, but nuclear energy, we either have nuclear fission or nuclear fusion. The nuclear fission happens when you have a large particle or a large atom and it breaks apart into two smaller ones and it releases energy. This is how we can get energy from nuclear power plants. We also have nuclear fusion, and that's when two smaller atoms join together to make a larger atom, and they release energy in that process as well. And that's what powers the sun. That's what's happening in the sun, how the sun keeps on going, okay? Nuclear energy is a form of potential energy because that energy is stored in those bonds as they're broken apart or as they're joined together. So what is an energy transformation? So in a second, we're going to look at the law of conservation of energy, and that's that energy isn't created or destroyed. It only changes from one form to another and so on. And so we're going to look at, well, if I want to use something, how is that energy going to be transformed from one form to another? Okay, so one of the things I want you to do, and I don't have time to put it in this recording, but I do want you to watch through this video on energy transformations. You'll have to maybe link on it below this video because it shows some really good energy transformations. So the law of conservation of energy, energy cannot be created or destroyed. It only changes from one form to another. For example, if I have a flashlight, I know that a flashlight has batteries in it. Okay, so batteries are a form of stored or chemical energy, and it's converted when I want to use my flashlight, it's converted into light energy, and it's also converted into heat energy. And one of the things you'll see is that there's often a loss of heat. We call that waste energy. We don't need our flashlight to be hot. We actually would prefer it not to be hot, but a lot of times we have that waste or that byproduct of thermal energy that happens as well. Okay, in chemical energy, so gasoline, I need to put gas in my car in order for it to work. And so that's a form of chemical energy. I put it in my car. My car then transforms it into heat energy, sound energy, light energy. It also transforms it into, well, we also have chemical energy in our car because of our car battery. So maybe you could have a combination of the battery and the gasoline. Chemical energy stored in food can be converted into mechanical energy so that you can move and ride your bike. If I want to turn on a lamp in my house, I might have to plug it in. So electrical energy is converted into light energy. Okay, we also know that light bulbs oftentimes get hot, and so we might have that waste of thermal energy. An oven here, again, might have to plug it in. It's going to form into heat energy. Ovens also have light energy as well sometimes. And this is showing how we can get light from the sun. And this, I would say, is electromagnetic. We could even go back and say it's nuclear energy because that's how the energy is created in the sun. And that can grow plants, which is a form of chemical energy. Okay, so energy transforms just from one form to another. Okay, oftentimes we have heat lost as a byproduct, but the total amount of energy is always conserved. It always stays the same. Now that you're finished, you are going to write your summary. So our essential question was, what is energy? Energy is the ability to do work. There are many types of energy, and then you're going to add 3 more sentences at least talking about some of the different types of energy or energy transformations. All right, please go back to this slide or the link below and watch that energy transformations video. It shows some more really good energy transformations if you're still a little bit stuck on that.